So the first one, what you want to do, I'm question number 28, right? You want to figure out the mean, the median, the mode, right? So the way to do this is to go to stat, all right, edit, enter, and you enter those numbers, right? So 5, enter, and then 10, enter, 6, enter, 100, and then 0, and then 0, and then 10, and then 0. Okay, once you enter everything there, you want to go to statistic again, and you want to calculate this, enter the first one, right? And make sure it is list L1. You don't have any frequency, so you can skip it, and then calculate. All right, so what we got here is the mean, which is X bar, all right? The mean is going to be equals to 16.375, right? So we're done with the mean. The median you have to scroll down on the calculator, and you can see MED 5.5, right? So the median is done. The mode right now, the mode you're gonna get it. You have, well, the calculator does not give you the mode, but I think it's easy to figure out the mode. What's gonna be the mode, guys? Very good. So the mode 0 because it's repeated the most, right? Okay, you're all set with this.
All right, for 29, you might wanna.
Okay, for 29, you wanna do some work before this, and the work is to get the midpoint, right? Are we okay? So the midpoint, how can you do with the midpoint here? So what you're gonna do, the first number you can get it from here. So you're gonna be 30 plus 39 divided by 2. Are we okay? So 30 plus 39 divided by 2, use the calculator again. So I'm gonna 30 plus 39, enter. I multiplied, so I guess. All right, 30 plus 39. And that's divided by 2, right? It's going to be 34.5. All right. Now, what you want to do is you want to figure out the gap between the classes. Between 39 to 49, it's going to be a 10. Or you can see it here between 30 and 40, it's going to be 10 as well, right? So what you want to do is you want to keep adding 10 to the next one to get to the next midpoint. Are we okay? You don't need to do the midpoint again and again. So you just keep adding 10. So this is going to be a 44.5. The next one is going to be 54.5. The following one is going to be 64.5. And the following one is going to be 74.5. So those are your midpoints. This is going to be your new X. All right. So the X values, it will be that one. And then the frequency here, this is the frequency. All right. So the frequency is going to be the other numbers, right? So now what you want to do here, you want to find the mean, right? And that's basically it, right? So find the mean. So what you're going to do is give it to the calculator. All right. Again, before going to start and filling up the table, you might wanna clear the memory. So how do you clear the memory? You're gonna go to second and plus, all right, where the memory is, right? and you're gonna go to number 4. So number 4, we clear all the list. So once you clear the list here, and then you go to stat, you're gonna have an empty table, brand new. All right, so the old data is done. Okay, and now you're gonna use 2 columns. The first column you're gonna be the axis, that's 34.5, and then 44.5, and then 54.5. All right, 64.5 and 74.5. So that's the first column. The second one is going to be the frequencies, 3, 16, 52, 16, 13, and that's all the numbers, right? So once you fill up all the table, you're going to go back to statistics. You're going to calculate second one in stat, all right? And you're going to use the first one, so you're going to enter. So by default, the list here L1, so it's fine. However, here for the frequency, you need to type L2 in it. All right, make sure you have L2 in the frequency because we have 2 columns, right? So you're gonna do second and 2. That's frequencies, enter and calculate. So this should give you X bar. You can be 56.5. I think that's all what they asked for, right? Okay, number 30. So what we want to do in number 30, we want to find the standard deviation, and again, you want to give everything to the calculator to be done, right? So first thing to do is clear the table. You're going to go to second, and then plus, and then go to number 4, clear all the list, enter, enter. So now go to back to stat, edit, and make sure you are in the first column. So you're going to enter the numbers, find the standard deviation, right? So you're going to put 40, enter, 36, enter, 26, enter, 23, enter, 4, enter, and then 33. All right. And once we get the first column filled up, we're going to go back to stat. You're going to go to calculate the first one, 1 bar stats, and L1 should be fine. However, L2 should be empty right now. All right. So you clear L2. All right. And then you're going to go to calculate. And X bar, you're going to be 27. You don't need the X bar, you need the standard deviation. Here, I'm assuming this is the sample. So what they are looking for SX. All right. If you have any doubt, are you doing the population or the sample, please ask during the exam, right? Okay. So SX is the sample. You're going to go with 12.89. Oh, 89.96. If you round it, this is going to be 12.9. Are we okay, guys, with this? Okay, 27, how do you do the histogram, right? So what I need, do you notice here, if I have 4 to 5, for example, right? So 4 to 5 and then 6 to 7, I cannot end at 5 and then start at 6 at the same time. Doesn't make any sense? All right, 5 and 6 are not the same number, so I cannot start and end at the same time. So what I can do instead, I can come up with the new boundaries, right? So the new boundaries here. So do you see the difference between this number and this number, 5 and 6? There is a difference of 1, right? What does mean? It means half point you're gonna go to the 5 and half point you're gonna go to the 6. If that makes any sense, right? So the new boundaries is basically here. This is gonna start from 3.5 to 5.5. This you can start from 5.5 to 7.5. All right, and so forth. I can generate the rest of the boundary. So this is 7.5. You can start and at 9.5, and then 9.5 to 11.5, and then 11.5 to 13.5. All right. So basically, I add that difference. I split it into between the two classes. All right. So that's one way to do it. So what I can do, I can start with 3.5 here. I end at 5.5, and then start at 5.5, I end at 7.5, and then so forth. Right. 9.5 here. This is going to be 11.5, and this is going to be 13.5. Are we okay? You understand what I'm trying to do? This one, 5.5, yeah. All right? Is it? Let me do it again. 5.5. That's the number? Okay, so I hope this is clear. So now what I'm going to do, I'm going to see the frequencies. So for the first column, which is 3.5 to 5.5, I have 24, right? So the best way to do this is actually go and see what is the highest number. Usually we divide it evenly, but it's up to you what you want to get scaled, as long as it's going to be consistent. All right. So if I have one division, 2, 3, 4, 5, 6, 7, I have 7 divisions, right? So I guess each one of them is 10 would be appropriate, because I have 75, the highest number. I have 7 divisions. So I can do 10 here, 20, 30, 40, 50, 60, 70. All right. And then from 3.5 to 5.5, I'm going to go to 24. Make a good estimation. That's basically what you want to do. 24 is between 30 and 40, so you're going to be stopping here. So here I'm going to do a rectangle. All right. That's the first rectangle. And then I'm going to go to 30. I know 30, you're going to be somewhere here, a little higher. All right. So I'm going to do another rectangle again. That's 30. Yes. I'm doing the histogram. Yeah, you're right. I'll do the polygon later on. Good job. All right, so let's go to the next one. You're going to be 75. 75, you're going to be all the way here. All right, so I'm going to do another rectangle. That's not a rectangle, but anyway, let me do it again. All right, so that's 75. Then 60, 60 going to be somewhere here. So let's go up. And 11, you're going to be almost 10. So this is 11. Are we okay, guys, with this? So this is how you do the histogram. So she's right. I need to do the frequency polygon instead. Yes. What highest number divided by 10? All right. So the polygon, in order to do the polygon, you need the midpoints. All right. So the midpoints, either you're gonna find them here. All right. Either you're gonna do the midpoint over here. So 4 plus 5, you're gonna be 4 plus 5 divided by 2, you're gonna be 4.5, right? And then you can see these 2 points. So you can be 6.5, 8.5, 10.5, and 12.5. Are we okay? So now if you want to turn this histogram into polygon, frequency polygon, so you're going to represent each of these bars, each one of them by the midpoint and the highest point. So do you see the midpoint here is, am I recording? Yeah. So the midpoint is at 4.5, right? And the highest point, this one, so this is going to be the first point. The second point is going to be in between here, which is 5.5, 6.5, sorry. All right. The midpoint is going to be right here and so forth. So you are taking only these numbers. Are we okay? And then you're going to connect them together. So you connect this one. So, and then let's see. Okay. So as you see here, it didn't go all, it's still open. So whenever you do what we do in the end, you go back to 4.5, you take away 2. So if you take away 2, you're going to be 2.5. And then you connect it here to 0, right? And the same thing for for this one, it is 12.5. Add 2, you're going to be 14.5. And then you connect this one with 0. So this is the frequency polygon. So the frequency polygon and the histogram are tightly connected. Are we okay? So 26, they give you a raw data and they ask you to do construct the histogram for the data, right? All right. So they are not doing the probability histogram, they are doing the frequency histogram here, right? So the thing, how did I know that? Because they are giving you the frequency in numbers. All right. Okay. So what do you want to do? Again, you need to figure out your table first. So the table, they give you the first class. So what does mean the first class? They give you from 0 to 9. That's what they give you the first. So you want to count how many from 0 to 9. And then whenever you start from 10. 10 to what number next one? 19, very good. You want to keep the same width of the class, right? So this is the X class. So, and then from 20 to 29. I don't know if you're going to go all the way to 30. Yes, we do have 30. 30 to 39. All right. So now the frequencies, what you want to do, you want to calculate, figure out how many are between 0 and 9. This is 1, 2, what else? 3, 4, 5, 6, 7, including 9, right? So this is frequency 7. We are okay? And then you're gonna figure out how many they are between 10 and 19. So this is 1, 2, 3, 4, 5, 6. So this is gonna be a 6. And we want to figure out between 20 and 29. 1, 2, 3, 4. There are 4. And finally, we want to figure out between 30 and 39. This is 1, 2, 3. Are we okay? And well, they give you the frequencies here between 0 and 9. So this is going to be somewhere here. This is somewhere here. I'm making the same width of each bar, right? And then you're going to see 7. So for example, 7 here, I'm going to go all the way to 7. So 7 is here. So I'm going to make a bar going to 7. That's the first bar. Then 6. 6 is here. So I'm going to go to 6. That's 6 already done. And then I'm going to go to 4. 4 right here. That's 4. And then 3. 3 right here. And you're all set. So what the meaning of this? It means that these numbers here, they are in fact not only one number, they are two numbers, 29 and 29. You see, 9 is the one digit, and this is the 10th. Are we okay with this? Okay. So if I go to the next one, what is the next one? What are the numbers from the next one? Oh, they are 30, 30. What are the numbers? No, 30 again, because I have two zeros, right? It means 30 and 30. And then what the next number? 31, 31, 32, 35, 38, 39. Everybody okay with this? And so forth, all right? Yeah, very good. So the other one, 41, 42, 43, and so forth, right? If I go all the way to the bottom, I'm gonna find the biggest number, which is 71 and 72, right? Everybody okay with this? So then you get it. The oldest age is gonna be 72. The youngest age is gonna be 29. So for this example here, what the meaning of the first bar? The number of TV sets, one TV set. How many families they have one TV set? They are 20. All right. So that's 20 family already involved. And then how many family they have two TV sets? And then 50 of them, right? So that's another 50 involved, right? Are we okay, guys, with this? So what you want to do, you want to add all these frequencies here. This is going to be 25. This is going to be 10. And okay, 25 is 3 TV sets is 25 right here. Oh, 15, you're right. So that's 15. And then this one, you're going to be a 10. And then this one, you're going to be a 5. All right. So then you're going to add them together. So this is going to be 70, 90, 100. So in this histogram, 100 family are involved, right? So what I'm going to do here is I'm going to do the x's. All right. So the first x is going to be a caramel, right? And then this is the frequency, right? So we have 100 caramels. We have mint, 83, chocolate, 93, and the nuts, they are 80, and then peanuts, they are 79. All right. So now what I want to do with this table, I want to represent it in a circle. We good? And this circle, I have to divide it accordingly, right? So each proportion is going to be exactly the same. So what I want to figure out, obviously, I'm going to start with the line here, and then I'm going to do like what piece of the pie is going to be corresponding to the first part, right? So what I want to do, I want to do the angle. Are we okay with this? So here you're gonna happen that you will have to use your proportions. So what I want to do first, I want to do the total here. I want to figure out what the total of all these frequencies first. So I might need the calculator right now. So let me see if I can switch. Okay. So the numbers are 100 plus 83 plus 93 plus 80. I don't know what I did. Plus 79. So the total is going to be 435, right? Are we okay, guys? So what's the meaning of this? If I had a proportion here, I have the degree, and what I have frequency, right? So guess 360 degrees, it will correspond to what frequency? It will correspond to 435. That's the total number. 435, the total number of frequencies, is corresponding to 360 degrees, right? Then if I want to figure out 100 right now, if I want to figure out 100 in the frequency, what will be the degree corresponding to it in X? I will have a proportion. Are we okay, guys, with this? So what I'm going to do X divided by 360. It's going to be equal to 100 divided by 435. Solving for X is going to be 100 divided by 435 times 360. So in other words, this what's it going to be? It's going to be the frequency times 360 divided by 435. Sorry. You got it? So I'm just giving you the formula right now, right? So that's how I get the formula. And what I want to do is I want to just figure out the angles. All right, so yeah, copy the formula. So I just want to figure out the angles right now. So the first one I'm going to use, let me do it here on the side. So I'm going to multiply 100 times 360 and divided by 435. And that's going to give me 82.75. You can round it to 83, let's say, right? 83 degrees. Are we okay with this? So what I want to do here, this is 83 degrees. And then I'm going to do again with the other numbers. So let me go here and do it. So again, the formula is going to be whatever the frequency is. So 83 in this. I'm going with the second the mints, right? The mints are 83. I'm going to multiply it by 360 and divide by 435. That's 68.68 or 69. So I can round it to 69. Are we okay? So the second one is going to be 69. And the following one is going to be 83. So I'm going to do, on my calculator, I'm going to change this one to 93. And that's going to give me 76.9, which is 77. And then the following one is going to be 80. So I'm going to substitute this one by 80. And that's going to give me 66.2, which is 66. And the last one is going to be 79. 79 is almost 77, right? 77, 79 here. Yeah, 65. You're going to be 65. Sorry. All right. So what happened here, the angles, they are not really nice. But anyway, so you just have to measure at your best abilities, right, the proportions. So we know 90 degrees. If I'm going to go to 93, probably a little less. So this is going to be somewhere here. So this is going to be 83 degrees. And then 69, so you're going to be 69, probably going to be somewhere like this. Yeah. So this is the caramels. I don't really know, but I'm doing the best. I don't have the tools here to measure. So remember, you have multiple choice again, and you are supposed to figure out which one the best choice. Hopefully, they are not really close to each other. Like I see 83, 69, 77. They are pretty close to each other, right? So basically, we are dividing almost equally. It's something like this, right? Are we okay? There is not a small angle, too small or too big. That's basically what I'm saying. So this one, you're going to be the chocolate. So you're going to be 77. This one, you're going to be the 80, which is the mint, the nuts. And this one, you're going to be 65, which is peanuts, right? You just add the total here. All right. So adding the total, you're going to be what? Let's see, 20, 30, 31, all right? So the relative frequency is 5 over 31, basically the probability. All right. 11 over 31, 9 over 31, 5 over 31, and 1 over 31. What is the cumulative frequencies? So there is a relative, there is a regular frequency, there is a relative frequencies, and there is always the cumulative frequency. So what is the cumulative frequency? The cumulative frequency, you just put the 5 here in the beginning, and then you add 5 and 11. That's going to be 16. And then you're going to add out with the next number, right? So the 9 here, you add it to 16, you're going to be 25. And then 25, you add 5 to it, you're going to be a 30. And 30, you're going to go add 1 to it, you're going to be 31. So these are the cumulative frequencies. This here, the relative frequencies, and over here, you're going to be the regular frequencies. Okay, question number 22, guys. So what we want to do here, they're asking you about the relative frequencies, right? So do you remember how to get the relative frequencies? Midpoint? No. So relative frequency is basically probability. That's another name for probability, right? Okay. So what you want to do here, you want to get the total of all the frequencies. So if you add all the frequencies together, what's it going to give you? 31. Very good. So this is going to be a 31. So once you get 31, so the relative frequencies here. So All right, so the first one, what you're gonna do, you're gonna just do 5 divided by 31. All right, and then you turn it into percentage, right? So anybody get 5 over 31, please, for me? What's it gonna be in decimal? 0.4, 0.16. All right, 0.16. That's gonna be 16%. Are we okay? And then you're gonna do the same thing. 11 divided by 31. What's it gonna be here? 0.25, 35. Thank you. And that's gonna be 35%, and so forth, right? 9 divided by 31, 5 divided by 31, 1 over 31. So 5 over 31, we know 0.16, which is 16%. What about 9 over 31, guys? 0.29. That's 29%. And the last one, 1 over 31. .03, and that's going to be 3%. Please make sure whenever you add all the percentages, this is going to be 100%. Are we okay with the relative frequencies? Okay, let me add one more thing here. There are 3 types of frequencies. There is a frequency, a regular frequency that we have here. There is a relative frequency here. And there is another type of frequency. What we call it? Anybody remember? The question is ended, right? So the question is done already. So there is another type of frequency which is called cumulative frequency. So do you remember how we get the cumulative frequency? All right, cumulative frequency is, as I say, it's cumulative, right? So up to this level, up to from 0 to 60, how many, what the frequency is 5, right? So if I go all the way right now to 11 here, what's going to be the frequency? You're going to add them up together. And that's going to be 5 and 11, 16. You got it? And then if I go all the way to 9, what's going to be the frequency? No. 20? 20. What about 25? All right, what I'm doing here, I am always adding. All right, look carefully what I'm doing, right? I'm adding 5 and 11. I get 16. And then I'm going to add the next number to 16. It's going to be 25. And then add to 25, 5. You're going to be 30. And then add to 30 right now. Add the 1. What's it going to be? 31. So this is the cumulative frequency. So there is a cumulative frequency chart as well, which is like a histogram. It's going to be always going up, which is cumulative frequency polygon as well, right? All right, so question number 21. So what they want to know, they want to, one of the 4 techniques. So one of the 4 techniques is going to be either randomly, systematic, clustered, and stratified, right? They are the most common one. We learn more in the slides, by the way, and the book. We have like we have a few extra ones, right? So now what we got here, we got the word randomly select or generate the numbers, right? So because they are using random selection is going to be a random, the first choice. So this is going to be a random selection, okay? You got it? So what they are doing in this, basically they are giving everyone they are giving it a number. They don't know who's and who, they just have numbers. and then they're gonna randomly select the numbers, right? Randomly, basically, they don't know. It's like a lottery. It's like you put the numbers in balls, and then you turn it, and you pick one blindly, right? Okay, so that's a random selection. Following one. All right, so for this one, it's asking you to select every fifth, right? Every fifth, that's again be systematic, and you can see it here. Systematic, basically, you are following a formula or you are following something, right? There is every fifth, every second. It could give you another formula, and you plug the numbers, and you get it, so forth, right? But still systematic. Okay. Okay, for this one, again, you're going to be for number 19, right? Is it 19? Yeah. So number 19, we have cluster. So again, the difference between cluster and stratified, because the location, right? So they are getting the schools and they are interviewing all the teachers into the middle schools. Basically, you select at random the school, but basically the location that matter here, right? Anyway, so let's go to the last one of this. So you select 100 drivers under 45 years of age and 200 drivers over 45 of age. So this is basically the stratified one. Usually stratified, they divide it into groups, all right? And these groups here basically under 45, and this is over 45. Are we okay? So why is not cluster, by the way, this one? Because the 100 drivers here and the 200 drivers here, the 100 drivers, they could be anywhere, right? So it's not the location that is important. What is important is the age, the group age of them, right? Okay. Okay, let's do this, guys. Number 17. We wanna find the probability, all right, that selected crime was committed in a commercial area, and then there is a word given here. Commercial area, given that it was an assault. So if I'm going to write it down as a probability, so the crime is the crime giving, that's giving assault, right? So whenever you are doing this kind of conditional probabilities, your universal set will become the assault set. All right, so you're gonna go here, and this is gonna be your universal set. So your universal set is 30 plus 20. You're gonna be 50. Are we okay with this? So that's your universal set, 50 on the bottom. And then you're gonna see how many of them they were commercial. There were only 20 of them commercials, right? So that's gonna be 20 over 50 then. Are we okay with this? And if you simplify it, 2 over 5, I don't know if you're gonna keep it in a fraction or you're gonna keep it in percentage, 40%. 2 over 5 is 40%, right? And that's about it. That's all. That's all you need to know. All right, the probability here, the probability of commerce given is an assault. This is going to be the number. You can use probability or numbers, right? By the way, of commerce and assault divided by the number of assaults. You can use, again, probability, the probability of the commerce and assault divided by the probability of assault as well. So if I'm going to use the numbers of the intersection, how many we have commerce and assault? They are only 20. Over here, that's 20. And how many assault we have? We have 50, right? And that's basically it. The same thing. Okay, 14. The probability of E given F. This is going to be the probability of E and F divided by probability of F. Are we okay? So what is the probability E and F? Do you get it? I don't have it actually. So what I'm going to do, I'm going to go to my Venn diagram. No, actually it doesn't have much Venn diagram. So what I'm going to do, I'm going to use the probability of E and F plus probability of E or F. This is going to be the probability of E plus probability of F. Are we okay? And you see here, I have probability of E 0.4. So this is 0.4. I have probability of F 0.6. So plus 0.6 here. I have the probability of the union, which is 0.8. So this is X. That's missing, right? Is actually plus here. So if you're gonna solve for the X, what you're gonna be X? What would you add to 0.8 to get 0.4 plus 0 plus 0.6? That's gonna be 0.2, right? So this is the X is actually nothing else than the probability of E and F. So you understand how we get it, right? So then I'm gonna go back. Right now I have E and F is 0.2. Probability of F is 0.6. 0.2 divided by 0.6, you're gonna be, well, you plug it into the calculator and this is gonna give you 1/3, right? If you want it in percentage, it's gonna be 33.33%, or you can write it 0.33. Any question, guys, about this? Hopefully not. Number 15. The probability of F given E right now. I'm going to use exactly the same formula, so probability of E and F, or F and E, doesn't matter really. Let's put F and E. Divide by probability of E. So F and E or E and F is the same thing, that's 0.2. We got it already earlier. And we're going to divide it by probability of E, and probability of E is 0.4. That's going to be 1/2. 50%. All right, 16 here. For 16, the question is, find the probability that a resident plays poker, giving that they also garden. So there is a given word here, right? So do you see it? So if I want to write the probability here, this is the probability of a player going to play poker, giving is also garden, right? That's how I write it down, correct? Yes? So this, according to my formula again, is the probability of poker and garden divided by probability of garden, right? Gardening. Are we okay? So do we have poker and gardening together? And that will be will be 5%. So this is going to be 0.05. And gardening only, do we have gardening only? We do have gardening only. This is 15%, which is 0.15. If you divide these two together, this is going to be 5/15, or we're going to be 1/3, right? And you can write it down 0.33. Let me remind you about the formula again one more time. The probability of an event A given I have an event B is the probability of their intersection A and B divided by the probability of the bottom one, which is B. All right, that's the formula of the condition of probability, right? Okay, this is the conditional probability one more time, right? So what's going to happen here? You have two steps. The first step is to select one black card, and the second step to select another black card. So the first one that you're going to do is the probability of having a black card, and that's going to be 26 divided by 52. Everybody okay with this? And that's probability of B, right? The second one is the probability of B given is a B. You are selecting a black given the previous one is a black. You are not replacing it. So how many black cards left right now? Because 25, very good. And on the bottom, what's it going to be? On the bottom will be 51. Why? Because you did not replace it back. You understand? So now the question is none of these two, right? The question is none of these two. The question is what the probability of having a black giving black and black. The first one black and the second one black. Yes? And this is the path here to get it. So the path is this one. So if I continue here the path, this path is giving me the probability. This one is giving me the probability of black and black. And then how can I get it? By multiplying the probability of B times the probability of black giving black, which is going to be equals to 26/52 times 25 divided by 51. So 26 and 52, you can reduce it to 1/2. And then you're going to be 25 divided by 2. All right. I think it's crushed. So 25 divided by 2, 2 times 51, you're going to be 102, right? I don't think you can simplify this. So that should be your last answer, right? Okay, so let's start with the first one. So let's see here first. We have a bag here. So in this bag, we have 10 white. We have 12 blue. We have 13 red. And, oh, the bag is small. All right, so what else? Yellow, how many yellow? 7. And green here, we have 8 of them, right? And we get bigger bag. Are we okay? So the question again is asking you what is the probability of selecting one white and one blue. However, this question could be misunderstood in two ways, right? So the first way, if the question is asking about what is the probability of the first one is white and the second one is blue, all right, that's going to be the conditional probability. So what does it mean? That means it means I'm going to select probability of white first, and then I'm going to select blue, right? Are you following me, guys? So what's the probability of getting a white here? We have 10 out of how many in total? 10 out of 50. And then the probability of getting a blue given is a white, that's going to be? How many blues we have? 12. How many left? 49, right? Okay. So now the probability of getting this is going to be the product. So this is the product here. And that's what is the probability of the first one white and the second one blue. And that's going to be literally 10 over 50 times 12 over 49. All right. And you do your simplification. I think you can simplify by 5. So this is 1 over 5. So 1 over 5 here times 12 over 49. I think you cannot simplify further. So this is going to be 245 and 12. All right. That's one way to do it. Now, because they did not say the first one white and the second one blue, this is going to be what the probability of white and blue. And white and blue I can get it many ways, right? So what's it going to be here? We're going to do the old-fashioned way. How many balls are we selecting? 2. Out of how many? 50. So are you going to be C, 50, and 2? You got it? And then on the top, what I'm selecting right now, I'm selecting one white, right? Where I'm selecting it. So one white is a combination from 10, I'm going to select 1. And multiplied from the other one, I'm selecting 1 blue. How many blues I have? From 12, I'm going to select 1, right? And this is going to be, well, 10 times 12 divided by C52, all right? So you got to plug into the calculator and figure out. All right, anybody want to do this? No? Let me go here. Calculator. So combination, functions, clear. So what I said, I want to do 10 combination. Oh, I have to do this here. All right, combination 10 comma 2 comma 1, close the parentheses, times again combination again, and 12 comma 1, close the parentheses, divide by combination again, and 50 comma 2, close the parentheses. So it's going to be 0.0979. Yeah. 98. 0. So this one is going to be 0.098. If I'm going to do it this way, 12 over 245, what is it? Anybody get 12 over 245? What in decimal? 0.049. Right? Yeah. So usually this method, do you see whatever the number I get here is always the half of this. All right, because because this method that I did it in red is having white and blue and blue and white. You got it? They have both of them. So again, I don't know which one of them. What do you have on the answer sheet, guys? 0.49. So definitely then they ask for the first one white and the second one blue. All right. Again, during the exam, if you are not sure, ask. All right. We got it. All right. So for this question, we are looking for a chosen parent. So we are talking about parents, right? Would agree or strongly agree that the school is clean. So where is the school is clean here? The school is safe in the top, the school is clean on the bottom, and you're going to be agree 135, strongly agree 49, right? So the probability you're looking for, so P going to be equals to 135 plus 49 divided by 500, which is right here, right? Otherwise, you will have to add all the numbers together. Are we okay? And that's basically it. So this is going to be, I don't know if it is a decimal or not. So what is it? 135 plus 149. Huh? Thank you. Are we okay, guys, with this? So they ask you to the nearest hundredth, right? So what is the nearest hundredth? 0.37, right? Okay, next one. Okay, so the probability here that you're looking for is going to be equals to the probability of getting one grape times the probability of getting one cherry times the probability of getting one lemon, right? Or because you are replacing the gumball every time, so you're going to take how many, what the probability of having a grape? There are 300 grapes divided by the total, which is 1200. And then you multiply it by the cherries, how many? 400 divided by 1200. And then because you replace it again, the lemon, they are 500 divided by 1200. All right, you want to plug this into the calculator and see what's it going to give you. All right. I believe it's a decimal. If it's not a decimal, turn it to fraction. Anybody got this? All right, and in decimal? Zero point 0.034. That's fine. All right, so for this question, the formula that you should use is the probability of A union B plus the probability of A intersect B. This should be always going to be the probability of A plus the probability of B. Are we okay, guys, with this? So what you can do here right now, you can fill up whatever you got. So A union B is this one, 0.65. The probability of A is 31, so this is 31. The probability of A and B is 13, so this is going to be 0.13. And the one that you're missing, how is you going to have one missing? All right. So the one that you're missing is going to be called X, and you solve for the X. Simple enough. All right. So for this case, if I'm looking for X, it's going to be 0.65 plus 0.13 minus 0.31. All right. So the probability of X is probability of B. What's it going to be? This one, 34 and 44, 47. Is it 047? That's what you got? Okay, nice. We get the first one. Okay, the second method, you can use the Venn diagram here. So this is your two circles, A and B. All right, so if I am using the Venn diagram, I want to use the intersection first. So 0, 13, right? So 0.13 is over here. Then I'm going to go to the A, probability of A, which is 31. This is A, 31. So if it is A 31 and I have 0.13 there, so what's it going to be? Whatever remaining? 31 minus 13, right? That's it going to give you 0.18. Very good. Now, the next one, what I have the union. The union A, union B, which is this one. So A union B will be the two circles together, this and this. And as you notice here, there is only one section missing, right? So the A is already 0.6, the A is 31. So these two, 18 and 13, is going to be 31. And what you are missing to get the 65, you're going to take it away from 65, and that's going to be 0.34, right? Are we okay? All right, so what we are looking for right now, we are looking for the probability of B. So the probability of B is going to be, what's it going to be in here? All right. And if you add it together, 13 and 34, you're going to be 0.47. So it work out anyway, right? All right, so what we got here, the probability of passing math is 0.4. This is the probability of math. And then what we got, again, the probability of passing English is 0.6. So this is the probability of English. And the other sentence here, the probability of passing at least one, all right? The probability of passing at least one, this is going to be the probability of math or English, and that's going to be union, right? Are we okay, guys, with this? Now, do we have the intersection? What is the probability? Actually, that's the question, right? What is the probability here of passing both of them? Both of them means math and English, right? So the probability of both of them means math and English. That's what we are looking for here. Math and English is the intersection, right? Okay, so again, I will go with the formula again. So that's the easiest one. So the probability of math and English plus the probability of math or English, that should be equal to probability of math plus the probability of English, right? And you can go ahead and substitute the values. If you don't see it, just mean put the X on it. So the end is the X plus the union can be 0.8. The probability of math is going to be 0.4. The probability of English 0.6. We good? So if you solve for the X is going to be 0.4 plus 0.6 minus 0.8. And that should be the probability of math and English. And that's going to be 0.2. All right, so again, what you need to do here, you just need to do a table, try to do, so this is number 6. So what you get 2 ranking, a professor ranking we have a professor ranking, and we have a teacher assistant ranking, right? And in each ranking, we have two categories. We have the male and we have the female, right? So for the professor, we have 5 males and 10 females. For the teaching assistant, we have 14 male and 9 female. So the picture is easier right now to digest. What we can do here, we can go and if a person selected at random from a group, find the probability here that the selected person is teaching assistant or a female. All right. So I'm going to go select all the teaching assistant. This is the teaching assistant. Everybody okay? And as well, I'm going to select all the female. So this is going to be the females. So if you double shade, you don't count it twice. That's basically what you need to keep in mind, right? So if you're going to do the probability that they are looking for, basically they are saying teaching assistant or a female. This is going to be a 10 plus 9 plus 14 divided by the total. The total is 10 plus 9 plus 14 plus 5. All right. And I know what's it going to be 23, 33 on top, and on the bottom 38. The answer is either on decimal or fractions. What you have on the back. Somebody turn it into decimal, please, for me. Say again. Okay. Thank you. So 0.88, but it is fraction. That's good enough. Okay, number 7. So if I am looking for this one, right, find the probability of that the corn crops has either a worm infestation or corn borer infestation or both. So literally, I am looking for the probability of E union B, right? That's the union, correct? And again, I can use my formula. So the probability of E union B plus the probability of E intersect B. This is going to be the probability of E plus the probability of B, correct? And I have all the ingredients of the formula there except one. So this is going to be the X. The intersection, I have it here, the end is 0.09. The B, all right, the E is 0.24, and the B is going to be 0.17, right? So then if I am solving for X, what's it going to be? 0.24 plus 0.917 minus 0.09. Are we okay so far? And if I do that, this should give me 0.32. So the probability I'm looking for here is equal to 0.32. I hope this is correct. Please double check. All right, number 4. So what I'm going to do a table here. So it's going to be the X's and the probability of X. That's what I should do, right? So X and probability of X. So the possible values of X, what's the possible value of X, guys? The possible values of X is the dollar amount, right? So it can be a positive 76, or it can be what else? Paying attention? -9, very good. And the probability of plus 76 is going to be 1/20. And the probability of minus 9 is going to be 19 over 20, right? So if I'm going to do this by the slow method, what I'm going to do, the expected value is going to be the sum of the xi's times the pi's, right? So you're going to be the sum of 76 times 1 over 20 minus 9 times 19 over 20, right? Okay, you can plug it into the calculator and figure out what's going to be. Anybody get the answer? Okay, so if I plug it into the calculator, this is going to be 76 times, open a parenthesis, 1 divided by 20, close the parenthesis, and minus 9 times 19 over 20, right? Are we okay? Oh, that's minus 4.75. Okay, now let me show you how to do it with the calculator the other way. So what you can do is you can go to stat, edit. So if you have any values there, what you can do, you can go second, you go to plus, second plus, you go to the memory, and then clear all the tables, right? Clear the table and go back to stat. Edit. So you have a clear table right now, right? So now what you see the x's and p of x's, right? So I'm going to start with the x's. The x's is 76, enter, and then minus 9, enter. That's it. And then I'm going to go to the next one, next column, and I'm going to have 1 over 20 and 19 over 20. It doesn't matter if you put a probability, 1 over 20 or 1. I can put 1 as a frequency, for example. So, and then 19 as a frequency. Both of them will give you the same result. All right, instead of probability at 2 frequency. If they are over 20, it's fine. If you don't know what is it, just put the probability, it's fine. Okay with this? Now, if I go to stat again and calculate right now and enter, I want to make sure that the list is in L1, and I want to make sure that the frequency is in L2. So I have to do second and 2 to type L2 there. Then you're going to go to calculate and enter. And what you get the X bar. That's what we are looking for. You see the X bar on the top is minus 4.75, which is the same answer. All right. What are the benefits of the calculator? That calculator doesn't require that you remember your formulas for the mean or for the standard deviations. Okay. Okay, number 5. What you want to do again, you want to do again the table. Every time you have expected value, you want to grab the table, express everything in table, right? So I'm going to have X values here and the probability values here. So okay. Now, whenever we have this, what you're going to do is what the value of the X is. The value of the X, it can be $1,000. It can be $500. It can be 100, or it can be -4, right? So you're going to be here 1,000, 500, 100, and -4. Are we okay, right? Now, for the frequency or the probability, the total number of tickets, they are 1,000, right? So if they are 1,000, I am dividing by 1,000 all the time. And then I'm going to look for what the frequency of 1,000. There is only one ticket, so 1 over 1,000. That's the probability. How many tickets are of 500? 1, so 1 over 1,000. How many tickets of 100? 8, so 8 over 1,000. That's the probability. And how many tickets are losing $4? So in order for you to lose, oh, I made a mistake, I think. Yes, I made a mistake. I'm going to fix it in a moment. In order for you to lose, what you need to do? You need to play and not winning, right? So how many not winning any prize? If in total the winning prizes are 10, right? 1 and 1 and 8 are 10 prizes, right? So in total there are 10 people they're going to win, and the remaining out of the 1,000, which is 990, they are losing. So what the mistake I did, actually there is no winning of 1,000. What is it instead? Nobody gonna win $1,000. You remember the winner of $1,000, what he has to do in the beginning? He has to play, right? You cannot win without playing. So if you play, you're gonna lose already $4. You got it? So here, everyone is losing $4. All right. So the actual value of the x's, I have to change them. So the actual value here is not, it can be 996. You got it? The value over here as well. So the value over here, you're going to be 500 minus 4, you're going to be 496. And 100 minus 4, you're going to be $96. So that's the winning. Everybody okay with this? Now, if I'm going to have to do it by hand, the expected value is going to be kind of annoying. The sum of xi's times pi's. And this is going to be 996 times 1 over 1,000 plus 496 times 1 over 1,000 plus 96 times 8 over 1,000, and then minus 4 times 990 over 1,000. And obviously, you do not want to do this. You don't want to do it by hand. So what you want to do, you want to go to your calculator. So remember, you're going to do it on statistics. So the first thing before starting the calculator, you're going to go to second and plus, enter to the memory, and you go to number 4 here to clear all the list. Enter and enter, done. So now I'm going to go to stat. I'm going to edit. So I have the table is empty, so I'm going to have to fill up the table. So the first number is going to be 996. Enter. The second number is going to be 496. Enter. Third number is 96. And the last number is going to be minus 4, right? That's my first column. The second column is going to be the frequencies. You don't have to put the probabilities. You can just put the frequencies. So the first one is going to be 1, second one 1, and the third one is going to be 8, and the last one is going to be 990, right? Are we okay? And again, you're going to go to stat right now, and you're going to calculate 1 bar stat. Make sure the list is L1. The frequency is L2. So you need to have a frequency here, right? Okay, enter, enter, and then calculate. And then you end up with the X bar. X bar, which is equals to minus 1.7. So on average, they are losing $1.7 per game. All right. Okay, let me finish this question. So find the expected value of a person buying 5 tickets. So 5 tickets here, it means every ticket is gonna cost you 1.7. So if you multiply it by 5, this the expected value of 5 tickets. I'm gonna call it E5. The expected value for 5 tickets is gonna be minus 1.7 times 5, and that's going to be minus $8.5. Okay. All right, so question number 3, I want to figure out the expected value. So the expected value, if I have to do it by hand, please don't do it by hand, by the way. Do it only with the calculator. So here the expected value is going to be the sum of xi's times pi's. So what does mean? It's going to be 2 times 0.4 plus 3 times 0.2 plus 4 times 0.1 plus 5 times 0.3. So this is the expected value. Now, I don't want to do that like this. I want to do it with the calculator. So how can I do it on the calculator? I can go again with the memory, clear the tables. All right, so that would be number 4. Enter, clear. And then you go to statistics, right? Add it to your table on statistics. So in the first column, I'm going to enter the x's, which is 2, 3, 4, and 5, right? And on the second column, I can put either ways. I can put either the probabilities or I can put the frequencies. Both of them should be correct. So if I have to put the probabilities, it's going to be 0.4, 0.2, 0.1, and 0.3. All right, that's done. You go to statistic again. You go to calculate, first one. So the list has to be in L1 and the frequency has to be in L2, and then calculate and you're done. So the expected value is the X bar, right? And that's going to be 3.3. Okay, question number 1, we want to figure out the odds of spinning picture below. All right, in favor of spinning A, in favor of spinning A. So what we can do, we can go with the Venn diagram. Here, this is going to be A. So in favor of A, how many A's we have? We have 1, 2, 3, right? And how many not A? 1, 2, 3, 4, 5. 5. All right. Are we okay with this? So the odds of spinning A going to be 3 over 5, which is 3 to 5 like this, right? Everybody all right, right? Okay. Number 2 then. Okay, number 2. So suppose that the probability of a female living in a particular country developing some cake recipe at some point of her life, yeah, right, is 1 over 7. Right, find the odds. Find the odds in favor against an American. Well, we say any woman in any country. We didn't say America yet, but anyway. So let's do this. We have the Venn diagram. This is the cake recipe, getting a recipe done. All right. Obviously outside not having a recipe, correct? Now, the probability of getting a cake recipe, what is it? 1/7? Yes? So how can you do that? 1/7. If I put a 1 here, what's it going to be outside? 6. Very good, because probability has to be the sum of both of them, right? Okay, done then. So what the odd in favor, against? Oh yeah, there's a typo there. It cannot be favor and against. Oh, they are two different questions. Either you are in favor or either against, right? Do you agree with this? All right. So the odds here in favor and the odds against. All right, the odds in favor of getting a recipe is 1 to 6. All right, 1 to 6. Against it will be 6 to 1. Are we okay? So the trick, it was to split the 7 into 1 and 6. That's it.